At first glance, an airport runway looks simple. It is long, it is flat, it is paved. There are some lines painted on it, some lights, and a fence, mainly to stop people discovering how expensive mistakes can be. Most people assume a runway exists in roughly the same way a road exists. Something poured once, something checked occasionally, something that mostly gets on with it. That assumption is reasonable. It's also completely wrong. What people wanted was straightforward. They wanted aircraft to take off, and they wanted them to land again, preferably without drama. Early aviation solved this by using fields, grass fields, mud fields, anything vaguely flat. This worked because aircraft were light, slow, and already unreliable in ways that distracted from the ground. If something went wrong, it usually wasn't the runway's fault. That didn't last. As aircraft became heavier, the ground stopped being a background detail. Landing concentrates force, a lot of force, in a very small area, very quickly. Grass does not argue, it simply gives up. Wheels sank, surfaces tore apart, aircraft slid in directions nobody had planned for. Flying was becoming manageable, stopping was not. This is when the ground stopped being scenery and started becoming engineering. A modern runway is not a surface. It is a load management system that happens to look like one. The visible pavement is only the final layer. Underneath it, subgrade soil is stabilized, and compacted base layers spread load sideways. Structural layers absorb repeated impact. The surface layer exists almost entirely for friction. When an aircraft lands, the force is not pushed straight down. That would be optimistic. It is distributed laterally, deliberately. If that distribution becomes uneven, braking becomes uneven. Uneven braking is not something aviation tolerates politely. Every runway has a pavement classification number, PCN. Every aircraft has an aircraft classification number, ACN. These two numbers decide whether an aircraft may use that runway at a given weight, at a given frequency. If ACN exceeds PCN, weight comes off. Movements are restricted or the aircraft doesn't go. There is no discretion. The runway does not care how full the aircraft is, or how tight the schedule looks, or how annoyed anyone becomes. Most runways are asphalt or concrete. Neither option is chosen because it looks nice. Concrete carries heavy loads, well behaves, predictably lasts a long time, but repairs are slow, and cracks are permanent statements. Asphalt flexes under load, absorbs braking forces, can be repaired overnight, but it degrades faster. And heat makes it impatient. Airports choose based on aircraft mix, climate, and how often they can afford to stop flying without triggering several meetings. There is no perfect surface, only one whose failures can be managed. Runways are not perfectly flat. They are crowned slightly. They slope gently along their length. They sit within strict geometric limits. These limits sound trivial. They are not. Slope affects drainage. Drainage affects friction. Friction affects stopping distance. Everything eventually leads back to stopping. Runway length is not a guess. It is defined by declared distances. Takeoff run available. Takeoff distance available. Accelerate stop distance available. Landing distance available. Each one describes a failure case. Accelerate stop distance assumes an engine fails at the worst possible moment and everyone immediately changes their mind. That distance must exist physically. Optimism is not an approved safety feature. Hot air is less dense. Less dense air means less lift, weaker engine performance, longer takeoff roll, which is why runways in hot climates are long. And why aircraft sometimes leave passengers behind, fuel behind, or cargo behind. The runway didn't get shorter. Physics just stopped helping. Not every runway sits where engineers would choose. Some are limited by terrain, some by noise rules, some by decisions made decades ago when aircraft were smaller and optimism was cheaper. They still work, but margins shrink. Performance calculations matter more, and nobody assumes there's spare runway lying around for comfort. Takeoff is dramatic. Landing is administrative. Once the wheels touch down, lift is deliberately destroyed. Weight transfers onto the tires, braking begins immediately, everything depends on friction. The runway does not stop the aircraft. It provides the conditions under which stopping becomes possible. The aircraft does the rest. Runway friction is tested using specialist vehicles. The results are reported as good, medium, poor. These are not opinions, they are limits. A poor report instantly changes landing calculations. If margins disappear, flights stop. No announcements, no speeches, just waiting. Every landing leaves rubber behind. Over time, it builds up exactly where aircraft land. Unfortunately, rubber is excellent at reducing friction, so the most used part of the runway becomes the least effective. This is resolved by blasting it off with industrial enthusiasm. A runway that looks worn has probably been looked after. A runway that looks pristine may simply not be busy enough to reveal its problems yet. Water is dangerous not because it's dramatic. Because it's thin. A shallow film lets tires ride on top of it. Braking becomes optimistic, so runways are grooved, not because it looks technical, because water needs somewhere to go. Smooth runways photograph well. Grooved runways stop aircraft. Only one of these matters. This is why landings sometimes feel decisive. A runway does not reward elegance, it rewards accuracy. Floating looks graceful. Floating also wastes runway, which is why some operators are noticeably uninterested in it. If you've ever experienced a landing that felt less like arrival and more like the aircraft being introduced to the ground with confidence, there's a reasonable chance Ryanair was involved. Not because anything went wrong, but because a firm landing puts the aircraft exactly where it's meant to be, exactly when it's meant to be there, with no unnecessary discussion. The runway absorbs it, because that's what it was designed for. At night, the runway stops being ground. It becomes information. Edge lights define width. Centerline lights define alignment. Threshold lights define where landing is allowed. Approach lighting systems extend the runway into space, providing depth and reference before the ground becomes visible. None of this is decorative. It exists because humans are terrible at judging speed, height, and distance in the dark. Runway lights change color. Centerline lights are white, then white, and red, then red. This is not atmosphere, it is a countdown. White means runway remaining. Red means you are running out of ground. The lights do not panic. They simply inform you that your options are diminishing. Runway markings are instructions. Numbers indicate magnetic heading. Threshold markings indicate permission. Touchdown zone markings show where repeated impact is expected. Pilots do not aim for the numbers. They aim beyond them. The numbers are legal advice, not guidance. Runway numbers are based on magnetic heading. The Earth's magnetic field drifts. Eventually, the numbers become wrong. When that happens, the runway closest charts are updated numbers the size of houses are repainted because the planet moved. The runway did not. Runways are designed for precision, but they are also designed for the possibility that precision might briefly take the afternoon off. This is why most runways don't simply end. They taper off into overrun areas, clear ground, engineered surfaces, or long stretches of gravel designed to be uncomfortable rather than memorable. These exist for aircraft that land long, or reject a takeoff late, or discover very suddenly that stopping exactly where planned was more of a guideline. Some overruns are just empty land. Others use engineered materials designed to slow aircraft down by sinking into them, converting speed into heat, noise, and paperwork. A lot of paperwork. None of this is optimistic. It's an admission that even with calculations, friction data, and very confident people at the front, things occasionally continue moving for longer than anyone was hoping. The runway doesn't panic. It just provides somewhere safe for the mistake to finish happening. At one extreme, you have fully engineered runways, layered pavements, grooving, lighting, margins everywhere. At the other extreme, improvised runways, flattened dirt, straight roads, cleared just enough to work. They function by removing safety margin and trusting that nothing unexpected will happen, which is efficient and fragile. Between those two sit constrained runways, not improvised, not generous, just built where space ran out before ambition did. Somewhere in this category sits Luton Airport, a runway next to a shed, on a hill, entirely compliant, just quietly expecting you to get it right. A runway is not impressive because it looks advanced. It is impressive because it behaves the same way thousands of times under conditions that are rarely ideal. It absorbs force, it removes uncertainty, it tolerates human inconsistency, and it does all of this while looking like a very long piece of ground, which is doing a surprising amount of work.